Well, hello everybody, this is Mr. Kinney. We're going over the matter not measurements, Unit 2, odd questions 1 through 15, the front of the page. There's a few typos, we'll get those. We zoom out. Notice we got a bunch of conversion factors, we got the base equation here. It will not be on the test. I highly recommend, if it helps you out, to go ahead and draw the equation triangle. DMV, Department of Motor Vehicles. So, question number 1 asks you to identify the following as either chemical or physical. So, anything that's, melting, boiling, freezing, condensing, stuff where you end up with the same chemical is going to be physical change. I'm going to do those first. Melting is physical. You end up with water. Boiling is water changing to a vapor if we're using water. That's physical. Vaporizing is going to be when you make steam from water. Soda pop bubbling. Basically, for the most part, you open up that soda, you're just letting it come out of solution, it's dissolving. That's just a physical change. It's going from being dissolved to undissolved. Condensing is when you have like dew forming in the morning, or the steam hits the cold bathroom mirror and you get water drops. Or in the summertime, you get a soda or an iced tea and you see the sweat, the sweat on the side of the container, and that's going to be physical. Now, tarnishing is usually like when silver rusts, when silver oxidizes. That is a chemical change. Oxidation always is a chemical change. It means you're adding oxygen to it and it's changing it. Rusting is when iron and oxygen mix, making iron oxide. Rusting, we just talked about it. That's definitely a chemical change. So there we go. Number 3, hydrogen gas, okay, reacts with water to produce, with oxygen to produce water. Hydrogen gas is what they use to power rockets. Oxygen is needed to allow fire to burn, and then water, we're very familiar. So I want you to list 2 properties. Well, for both of these, we both said they were a gas, so there's one property, they're a gas. Hydrogen is a fuel. It can burn. Oxygen is an oxidizer, which means you need it, needed for burning. And then maybe you got some other stuff, but anyway, that's 2 main things there, characteristics. Water is a liquid. Okay, now H2O, usually we're thinking water, but it's a liquid, L-I-Q-U-I-D, okay. It's very stable. I mean, these 2 things, you react them, bang, they blow up. They make water, which is very stable. You can add electricity to water and split it into those, but anyway, so it's a liquid, it's very stable, okay, and it's good, okay, like water. Okay, number 5, I want to draw and label an atom. So we're going to start with the inner part, the nucleus. The nucleus has protons and neutrons in them. P+, protons have a plus charge. Neutrons are neutral, they have no charge. And then let's see, now I've labeled this, I've done that. Include, okay, oh, the shell. Okay, now, so out here is going to be the shell. There's various models for it, but we'll just say it's the shell out here. And the shell has electrons in it with a negative charge, so I'm using E for electrons. Got that. Include the charges of the subatomic particles. Done. Label the atom. And now if we were to try to draw this to scale, I mean, like if this was how big the shell was, that nucleus, oh, that's maybe next unit. Anyway, there you go. There's the parts. These have mass. It's only the nucleus. Massive. They have mass. Very little small mass. Okay, moving on. Oh, wow. Geez, I'm so embarrassed. I have a typo on here. So, well, just go with it, everybody. So this is an even number, or an odd number, so let's go. Sorry. Go figure. How many, this is the second number 3. How many protons in 1 atom of gold? Well, when you look at the periodic table square here, this will tell you how many protons you have. That is what the atomic number tells you, number of protons. Coincidentally, before bonding occurs, every proton will attract an electron. So this will also tell you the atomic number, how many electrons if chemical bonding has not occurred yet. So let's see, how many protons in one atom of gold? 79. And let's see, number 5, oh, there's, yeah, there, round gold's atomic mass, to one place. So over here, we're going to round this to the ones place, a whole number. Well, since this is 6.9, 9 is bigger than 5, we'll round this to 197.0. That'll round that there to the ones place. Now let's see, I'm going to go to number 7 here. And, oh, I just can't do it. Okay, number 6, how many neutrons in one atom of gold? Okay, so for neutrons, you have to take your rounded atomic mass, 197, because that's how many neutrons and protons you have. We're going to subtract from it the atomic number, 79, because when we subtract that from it, it's going to tell us, it's going to take away the protons in there and just leave us with what's in the nucleus. So 197 minus 79 equals, ha! You can do that. All right, next one. Round gold's atomic mass, its atomic weight, to one decimal place. So on here, since we're going to this is one decimal place. This 6, bigger than 5, we'll make this round up to, well, 10 basically, which is going to pop this to 196.0. 197.0. We have to show that we've gone to that decimal place there. And the second part is to round it to 2 decimal places. So now we're going to this one right here. So we're going to have 196.9. But now this is the one. So this 6 will make this round to 7. So there we go. That's atomic mass units. Explain why the shell of an atom has almost no mass. Electrons, very tiny particle. It's almost a wave energy form instead of mass. Almost a wave energy thing. It's got characteristics of both. Oh, wait a minute. Let me get that there. Number 9. Getting to go to scoot up. So again, electrons, very tiny particle. They're almost wave energy. Number 11. Explain how you determine the number of neutrons in an atom given the periodic table. Well, you round the atomic mass to whole number. In the case for gold, that would be 197. Then subtract the atomic number. Subtract atomic number. For gold, minus 79. This is protons plus neutrons. This is just protons. So when you subtract 79, you're subtracting those protons. Oh, cool, look at here. Okay, I've got another number 11. Okay, don't laugh at me. Okay, don't laugh at me. Go ahead, laugh at me. I do it all the time. So, what is the atomic, because I'm hilarious. What is the atomic number of helium? Well, here's helium over here in our diagram. And, okay, so, atomic number for helium. I mean, we could look on the periodic table and see that helium, when you see it on the periodic table, has a 2 up there and a 4 here. But when we look at this diagram, the thing it's the same about it, because this is the nucleus, are the dark ones there. There's 2 of them. Its atomic number is 2 because, and now let's, oh, here's a 13. I skipped 12. Which circle represents the neutrons? Well, the neutrons are going to be the open circle. The neutrons are going to be those right there. Because with isotopes, you can have, in elements, you can have different number of neutrons, but the protons have to stay the same or it's a different element. You can become a skinny version of helium with only 1 neutron, or you can be the normal version of helium. You might even be helium that has an extra one. It's not very stable, not very common, but that could be possible where you have 3 neutrons, but as long as you have 2 protons, you're still hydrogen. Excuse me, you're still helium. So, which circle represents neutrons in here? Because the neutrons can change, the protons can't. neutrons can vary. Protons cannot vary in an element. Meaning by that, this is helium. Helium always has to have 2 protons or it's not helium. We're going to get to the last one for today. The mass of the nucleus comes from blank and blank. Fill in the subatomic particles. I know what you're thinking. It's these 2 particles right there. Protons and neutrons. There we go. I'm going to cut this today because I've got an appointment I got to go to. Bye. Stop. Hello. Quit.